The margin of error, E, for a confidence interval estimate of a population mean mu, can be found by multiplying the critical value t alpha over 2 and the standard deviation of the sample means. So this is a lot like what we did for confidence intervals for population proportions. So our margin of error is t alpha over 2 times s divided by the square root of n. And s is going to be our sample standard deviation. N is our sample size. Now again, the center of the confidence interval will be our point estimate, which is the sample mean, x bar, and the distance the interval spreads on each side is E, our margin of error. So the confidence interval will look like this. The lower limit will be the sample mean minus the margin of error. The upper limit will be the sample mean plus the margin of error.
Here's an example of constructing a confidence interval for a mean. For this one, we're going to do it two different ways. First, we're going to do it using the formula, and then we're going to do it using just Statcrunch. In this one, we've got a sample of 51 pennies, and we have some sample data. So we have the sample mean, sample standard deviation, and we want to construct a 95% confidence interval to estimate the mean weight of the pennies. First, we're going to do this with the formula. And even though we technically don't use the alpha the way we do this, in some of the problems that you get, it will talk about the alpha, so you really need to know what it is. The alpha is just 100% minus the confidence level. In this one, our confidence level is 95%, so our alpha would be 5%, or if you need it as a decimal, it's 0.05. We can use the t calculator in Statcrunch to find our critical value that goes into our formula. To use that t calculator, we need to know the degrees of freedom. That's going to be 1 less than the sample size. Our sample size was 51, so if we subtract 1 from that, we get our degrees of freedom of 50. What we're trying to do is find the cutoff values for the middle 95% of values, since we've got a 95% confidence level. If we do that in Statcrunch, we come out with a critical value of 2.009 if we round it to 3 decimal places. The other things that go into this formula for the margin of error, here's our critical value. This next value is the sample standard deviation, and then we're dividing that by the square root of the sample size. If we put those numbers into the formula and calculate it, we get 0.006 as our margin of error. Then to find the lower and upper limits of our confidence interval, we're going to take the sample mean weight that was given in the problem, which was 2.464 grams. We're going to subtract the margin of error to get the lower limit for the confidence interval, and we're going to add the margin of error to get the upper limit for the confidence interval. Here are our lower and upper limits, and we can write our confidence interval in interval format, which means we put the lower limit first and a comma and then the upper limit in parentheses. Here's another way to find this confidence interval just using Statcrunch. In Statcrunch, since we've just got the numbers and we don't actually have a data set, then we can just go to the data editor, whether it's got data in it or not, and do stat, tstats, one sample, and we're doing this with summary since we don't have data. This window will come up and it will ask us for these 3 values, the sample mean, the sample standard deviation, and the sample size. Then we also have to tell it we want a confidence interval and put in the correct confidence level. When we click on compute, we'll get this set of results. The important things here are the lower limit and the upper limit. Those are the 2 limits for our confidence interval. That gives us our confidence interval for the mean weight of the pennies, which is from 2.458 to 2.470 grams.